We're going to go ahead and jump into Unit 2. Our first section is going to be corresponding to the unit, the Newton assignment, Cartesian coordinate system and graphs. So there's several topics kind of thrown in here. So we're going to try to lightly touch on each of them. Okay. So first of all, whenever you see coordinate system, you should basically just be kind of thinking of the XY grid that we use whenever we graph our functions, okay, or our relationships. So I'm going to just go ahead and just say basically the XY grid we graph our equations or functions on, okay? Basically the XY grid that we graph our equations or functions on, okay? Another terminology or verbiage that you need to be aware of is when we talk about ordered pairs, okay? An ordered pair we write as x comma y, okay, with parentheses around it. It's not an ordered pair if it doesn't have those parentheses, okay? And what this represents is just an input and output point on this graph, okay? So I'm just going to say x is our input and y is our output. Okay, and whenever we graph these, our x is corresponding to the x-axis, which is our horizontal axis. Okay, horizontal, and y is our y-axis, which is our vertical axis. Okay, vertical. Okay, so when we talk about our x's, we're going left and right. When we talk about our y's, we're going up and down. Okay, and this coordinate system is broken into 4 different parts. And we call those our quadrants, okay? So the 4 areas of our coordinate system or our grid, right? Okay, and we label them with Roman numerals, okay? Let's see, 4 areas of our coordinate system. Let's go ahead and say separated by the x and y axis, and we're going to label them with Roman numerals. So we're going to have Roman numeral 1, 2, 3, and 4. Okay, so let's go ahead and look kind of what that looks like down here on our graph. So this whole grid right here, this is our coordinate system. Okay, you can see here we have this labeled as our y-axis. Our horizontal is our x-axis. So we have a little x there, right? And then these are our 4 quadrants. And we always start here in the quadrant where x's and y's are both positive. This is quadrant 1. And then we go counterclockwise. So this is quadrant 2, quadrant 3, and quadrant 4. Okay. So what I want to do is just kind of refresh on graphing, and I'm sorry, my paper here did not print very well, so hopefully you can see your dots and your lines better than I can see them on mine. So what I want to do is I just want to take these plotted points A through E, I want to write the corresponding ordered pair and then list what quadrant they're in. Okay, if a point happens to land on an axis, then it's actually between 2 quadrants, and so we'll just list the axis that it's on. So I'll do the first one, and then I'll let y'all pause the video and do the others, okay? So for point A, I see point A is here in quadrant 2, so I can go ahead and say this is in quadrant 2, and then I want to write this as an ordered pair. So notice if I drop this down right here, that's at the point -3 on the x-axis, and it's over here at the point +2 on the y-axis. So as an ordered pair, I would write point A as -3, 2. Okay, so I want y'all to take a minute and do B through E. Go ahead and pause this video, and whenever you get done with that and you're ready to check your answers, go ahead and play the video again. Okay. All right, so hopefully you've had time to write down the ordered pairs for each of those points. B is over here in quadrant 3, and this point is over at -12 and then down 3. So -12, 3 would be that one's ordered pair. When we look at point C is right here on the y-axis. So notice for quadrant, I just wrote y-axis. Okay, and to get to this point, notice on our x-axis, we're not going left or right from this origin point. So that means its x value is 0, okay? And then its y value is down here at -8, okay? For point D, which is up here in quadrant 1, notice from our origin, we're going to the right 4 and then up 10, so that's the point 410, and it lies here in quadrant 1. And then our last one, E, over here is in quadrant 4. And to get to E, we're going to the right 6 and then down 11. So that means our x value is 6 and our y value is -11. Okay, so now I kind of want to do the opposite. Instead of looking at a point and finding its ordered pair, I want to give you an ordered pair and have you plot it. So I'll show you one, and then again we'll have you work the rest. Okay, so for point F, we want to graph the point -11, 9. So if I look on my graph here, remember this first coordinate is our x, the second one is our y. So I'm going to where x is -11, which is over here, right about here. I'm going to write kind of big on my paper so that y'all can see it. Okay, and then my y value is 9. So up here at 9. Okay, so when x is at 9 and, or sorry, x is at -11 and y is at 9, my point should be right here. Okay, so that's my point, and I'm just going to label it with an F. Okay, so that's what I want y'all to do through for G through J. Okay, is go ahead and take that ordered pair, plot it up here, and then just label it with the letter that's next to it. Okay, so go ahead and pause the video, and then whenever you're ready to check yourself, go ahead and play it again. All right, so here are the worked out answers for G, H, I, and J. G should be down here in quadrant 4. H should be up here on the y-axis. I is down in quadrant 3. And J is over here in quadrant 1. Okay, so take a minute and correct yours if you didn't get the right answer, but we're going to go ahead and move on to the next topic for this section, which is the midpoint, finding the midpoint of 2 points. And the midpoint of 2 given points is basically the point in the exact middle of the distance between the 2 points. Okay, the point in the exact middle of the distance between those 2 points. Okay, and we have a formula to help us find this, right? If we have 2 things and we want to find the exact middle, basically we can just average those 2 things, right? So that's what our midpoint formula. Now, because it is a point, we want to make sure we write it as an ordered pair. Very important. Okay, so this is an ordered pair. And what we're going to do is just exactly what I said. We're going to average our x values and we're going to average our y values. So we're going to take our 2 x values, we're going to call them x1 and x2, add them together and divide by 2 to find that center x. Okay, then we're going to do the same thing with the y's. Add our 2 y values, which we're going to call y1 and y2, and divide them by 2 to find that center y value. Okay, so I'm just going to say this is 4 points x1, y1, and x2, y2. So if we're given any 2 points, we can find the midpoint by basically just averaging their x's and averaging their y's and writing that as an ordered pair. Okay? All right, so let's look at some examples, shall we? All right, so on this first one, we can go ahead and label these x1, y1, x2, y2, or you can just do it in your head. I'm not going to require that you write, the little labels on there. So if we want to be able to find the midpoint between these two, I want to add my 2 x values together. So I have -6 plus a -4, divide that by 2. And then I want to be able to average my 2 y values. So I have 2 plus 8 divided by 2. Okay, and then from here we're just simplifying. So -6 and -4 gives me a -10, which I need to divide by 2. And then on my second one I have 2 and 8, which gives me a +10 divided by 2. Okay, so I simplify, which is going to give me a -5, +5 as the center point between these 2 given points. Okay, not too bad. Let me do one more and then I'll have y'all try one. So on this one, same thing. This is my first x, my first y, my second x, and my second y. And I'm just going to plug it into that midpoint formula. My midpoint formula says to take the average of my x's. So my first x is negative 15 plus my second x, which is negative 6. Divide that by 2. And then average my y values. So my first y value is negative 2 plus my second y value, which is negative 4, and then divide that by 2. Okay, so negative 15 and negative 6 gives me negative 21. I want to divide that by 2. And then negative 2 and negative 4 gives me negative 6, and we're going to divide that by 2. Okay, now for most of these problems in your homework, we don't want decimal answers. So if you can reduce these values that are in your midpoint, do it. But if it doesn't reduce like this, negative 21 over 2, that doesn't come out nice. There's nothing I can reduce. I'm just going to go ahead and leave it as negative 21 over 2. Okay, but negative 6 over 2, that reduces to negative 3. Okay? I'm just going to leave it like that. Okay. All right, so there are 2 for y'all to try, same thing. So go ahead and pause the video, try those, and then when you're ready, replay the video to see the answers. All right, so on the first one, we need to average our x, which is 13 minus 9, right? Or 13 plus a negative 9, which gives us a 4 divided by 2 means our x coordinate is 2. When we average our y's, we get 9 from our first y value, negative 5 from our second. When we combine those, we get 4. Again, over 2 is 2. So our first midpoint should have been 2, 2. And then on our second one, we do the same thing, right? Average our x's. We have 3 and negative 11. You could write this as 3 plus a negative 11, or just 3 minus 11 is fine. Gives us a negative 8 divided by 2. Leaves us with a negative 4 as the x value of our midpoint. And then for our y's, we take our first y, which is 2, and add it to our second y, which is negative 3. 2 plus a negative 3 is the same thing as 2 minus 3, which gives me a negative 1 divided by 2 does not turn out pretty, right? There's nothing I can reduce, so I'm just going to leave it as a negative 1/2. Okay, all right, so that was midpoint. Now what we want to look at is we want to look at distance. Okay, we know how to take 2 points and find that midpoint, but now what we want to do is be able to take those 2 points and find the distance, the actual distance between them. Okay, and the distance between 2 given points is basically derived from the Pythagorean theorem. So I'm going to do a little sketch over here and then we'll kind of explain it a little bit. So when we talk about the Pythagorean theorem, that comes from a right triangle, right? So what I'm going to do is if I have any 2 points on a graph, I can connect them with a line, right? And if I want to know the distance of that line, I can just drop down and create a right triangle. Now we're not going to make you go through this every time, but I just want you to see where it comes from. So this is the distance that we're looking for, right? Is the distance between those 2 points. And what the Pythagorean theorem says is that this distance, because it's vertical, right? This is the change in y, right? This is my y is going from a y up here down to this y value of that point, right? And then this distance right here is the change in our x values, right? Because we're going from this point over to this point. So that's the change in that x value, right? And do y'all remember the Pythagorean theorem that says if you take this side and square it and this side and square it and you add it together, it equals to that side squared, right? So a squared plus b squared equals c squared, something we've seen before. So basically, if I want to solve this, I can square these changes and add them together, and then to get d by itself, I would take the square root of that whole thing. Okay, so I'm just going to write out kind of what that is that I just said. Okay, so the distance between 2 given points is determined and derived from the Pythagorean theorem. And I'm just going to abbreviate theorem, okay? And I'm just going to say we are basically finding the length finding the length of the hypotenuse of a triangle created by the 2 points given. Sorry, I kind of had to squeeze that in there. Okay, so our distance between the 2 points, we can determine and derive it from the Pythagorean theorem because we can create a triangle, okay, right? Create a triangle from these 2 points that are given, and basically we're looking for that hypotenuse length that's created by that distance, okay? So remember, if I did a squared plus b squared equals c squared, right? This would be my change in x. Sorry, this would be my change in x. This would be my change in y, and this would be my hypotenuse. So it's kind of like this is my a, right? Is subtracting my x values. This is my b, which is subtracting my y values, and then my distance is c. So I just kind of want to write that in there. So if I take my two x values and subtract them, x2 minus x1, and it's squared. And then remember, we're saying this is like our b, right? This is my a, my c. This is the change in my y, so that's like subtracting my y values. And then what it would give me is my c, my hypotenuse, right, which is my d value. Now, the Pythagorean theorem gives me this formula, but it gives it to me with my distance squared. So if I want to get rid of that square, then I just take the square root of both sides, right? So that I have just d is equal to. And that is actually where we get our distance formula, okay? So our distance formula is that d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and this is for any 2 points on the graph, x1, y1, x2, y2. So this is a formula you're going to want to remember, whether you highlight it, star it, add it to your note card, okay, that kind of thing. You will need to know this. I will not give it to you on an exam, okay? So this is our distance formula. So now let's just practice using it. You're not going to have to derive it with a triangle. I just kind of wanted to explain where it comes from, okay? So using this distance formula that we now know, I want to go ahead and find the distance between these 2 points. So I'm going to go ahead and label this one x1, y1 and x2, y2. Okay, again, you don't have to label them, but it's helpful when you're first starting out to make sure everything gets plugged into the correct place. So we have our distance is equal to the square root of, we do our second x value, which in this case is 4, minus our first x value, which in this case is 6, and we square whatever that equals, right? And then we're going to add it to another squared quantity, which is our second y value, which in this case is 3, minus our first y value, which in this case is -3. And then we're going to square that, okay? So I just want to simplify a little bit. Notice here I have double negatives, so that's going to become positive. And then I'm just going to write down here and keep simplifying. So 4 minus 6 gives me a -2 squared plus 3 plus 3 is 6 squared, right? And then I want to simplify these. So I end up with the square root of 4 plus 36, which is equal to the square root of 40. Now, I'm not sure in Newton if they let you leave it as the square root of 40, but I want to make sure that you know how to simplify a radical expression. Okay, so I just want to refresh on that. Okay, so if we have that our distance is equal to the square root of 40. Remember, a square root we can simplify if we have a perfect square underneath it, right? Or if we have 2 copies of a number being multiplied together underneath it, we can bring that number out. So I just want to show you how to break this down. So 40, we could go all kinds of different ways, right? I'm going to just start with 2. I know it's even, so I know that 2 goes into 40 20 times, right? I know that 2 is even, so I'm going to say 2 goes into 20 10 times. 10 is still even, so 10 goes, let's see, 2 times 5, right? So I want to see if I can come up with any perfect squares within this number 40. So I notice here I have 2 copies of a 2. Well, 2 times 2 is 4, right? So I can do the square root of 4. That's just 2. So anytime you see 2 copies of a number, that number comes out. So this means I can bring out a 2. Now notice I don't have 2 copies of any other number. All I have left are a 2 and a 5, right? And there I don't have 2 of either of them. So those are going to be stuck under this radical. So that means that my distance is equal to the 2 that I brought out, and then underneath my radical, the 2 numbers that are left over. So I was left with a 2 and a 5. So I'm going to go ahead and multiply those back together, which gives me 2 square root of 10. Okay, so again, Newton may let you leave your distance written like this, but it also may have you write it as a reduced radical. Okay, so either one of these is good, but I prefer that you go ahead and simplify it. Okay. All right, so let's go ahead and try this again. Let's look at this distance. So remember, our distance is equal to the square root. We take our second x value, which in this case, our second x is -3, and we subtract our first x value, which is -5. And then we're going to square that. We're going to do the same thing with our y's. We start with our second y value, which here is 0, and we subtract our first y value, which is 8, and then we're going to square that. Okay, so again, I have double negatives. Double negatives become positive. So when I keep simplifying, I have -3 and 5, which leaves me with a positive 2 squared. And over here, 0 minus 8 leaves me with a -8 squared, right? So I'm going to go ahead and see what those numbers equal. 2 squared is 4, -8 squared is 64, and 4 and 64 gives me the square root of 68, right? And then I want to go ahead and simplify that. So I got the distance is equal to the square root of 68, and I want to break this down and see if I have any perfect squares within that number 68 that I can pull out like I did on this last problem, okay? If we don't know what we can multiply together to get 68, we can always check and see if it's even, which this is, so we know 2 goes into it. 2 goes into it 34 times. 34 is also even, so I can take a 2 out, which leaves me with a 17, and 17 is actually prime, right? I can't go any further with 17. So notice I do have 2 copies of a 2, so again, that 2 comes out, and the only thing I'll be left with under my radical is 17. So my distance can be written as 2 square root of 17. Okay, not too bad. All right, so there are 2 for you to try. So again, pause the video and work it out, and then go ahead and play it to make sure that you got the right answer. Okay. All right, so when you find the distance of number 1, you should have ended up with the square root of 40. Okay. And then that one can simplify, right? I can make this as 4 times 10. 4 is a perfect square, which means I can bring out a 2. If you went ahead and broke this down as 2 times 2 and then pulled out the 2, that's totally fine. Either way, you end up with a distance of 2 square root of 10. Okay. On number 2, when you when you calculate your distance formula, we end up with a distance of the square root of 125. And we want to go ahead and break that down. It ends in 5. So I know it's divisible by 5. So when I break it down by 5s, I end up with 5 times 5 times 5, which means I have 2 copies of a 5. So I can bring out a 5, and then I have another 5 that's going to be stuck under the radical. So my distance is 5 square root of 5. Okay. All right, so we've gone over plotting points. We've gone over the midpoint of 2 points. We've gone over the distance between 2 points. The last thing that we're going to do in this little section is talk about how to find the corresponding points to a given equation. Okay, so in other words, if we're given any equations, we want to be able to determine the solution points, or the points that make up that line. Okay, so I'm going to go ahead and say these are solution points, and will make a true statement. Make a true statement when plugged into the equation. Plugged into the equation. Okay, so in other words, if we're given any equation, we want to know, can we find different little ordered pairs that are solution points to the equation that, or the line that this equation would make, okay? And the way we can check that is we can take each individual ordered pair and plug it in here to make sure it makes a true statement, or we can go ahead and just graph this line and then double check it against our homework and see what points line up on that line, okay? So that's how we're going to do it. I'm pretty sure in your homework these might be multiple choice problems. So make sure you graph it by hand so that you know where these points would be, and then you can easily determine which choice in Newton is your correct answer. Okay. All right. So we're going to go ahead and just pick some basic numbers, which I think are probably the numbers Newton will use to determine where some solution points are on this line. Okay, so I'm going to go ahead and just make an XY table and pick some generic type points. So we're going to pick -1, 0, 1, and 2. Okay, so to find some ordered pairs that fall on this line, we're going to take these points and just plug them into the equation. Okay, so if I plug in -1, I would get y equals -3 times -1 minus 4, right? So -3 times -1 is +3, minus 4 is going to give me a -1, right? So when I plug in -1, I'm getting -1. So -1, -1 is a point on this line. So I can go ahead and plot that point. Then I do the same thing with 0. I plug 0 in. Y equals -3 times 0 minus 4. Well, -3 times 0 is just 0, right? Minus 4 gives me a -4. So when x is 0, y is -4. Okay. So I want to go ahead and plot the point 0, -4, which is here. Okay. And then I want to quickly do the other two. Now that you know how to write it out, I'm not going to write that out for every single problem. So if I plug in 1, -3 times 1 is -3, minus 4 gives me a -7. When I plug in 2, -3 times 2 is -6. Minus 4 is -10. So I'm going to go ahead and plot these last 2 points. So at 1, I'm down at -7. And at 2, I'm down at -10. So these are all solution points to this line. Now, in your homework, it may just leave them like this. It may just leave them as points. But since this is actually representing points on a line, I'm going to go ahead and just connect them with a line so that you can see. Because there would be more solution points going this way. There would be more solution points going this way. So I always like to write it with a line. Okay. All right, let me look at one more, same idea. I'm just going to pick the exact same XY chart values to get a good approximation of where our solution points are. So I'm just going to pick -1, 0, 1, and 2 again, but now I have a different equation. So again, I'm going to plug this in just like I did before, and I'll go ahead and work out a couple. So y is equal to -5 minus 2 times the x in my table, which is -1. So I get -5, and then -2 times -1 is +2. So -5 plus 2 leaves me with a -3. So that is one of my solution points. So when x is -1, y is down at -3. Okay. So I'm going to do that, continue to do that for the rest of these points. When I plug in a 0, -2 times 0, that's just going to become 0, and I'll be left with -5. So that gives me the point 0, -5. When I plug in a 1, -2 times 1 is -2, and -5 minus 2 is -7. So at 1, I'm down at -7. And then my last one, when I plug in 2, -2 times 2 is -4, and -5 minus 4 gives me a -9. So at 2, I'm down at -9. So again, you can see our solution points. So if Newton gives you choices like this, you can easily identify which one are the correct ones. But again, because I know these are all solution points to this equation, which makes a line, I'm going to go ahead and connect the dots. Okay. All right, so there are 2 for you to try on the next page. Go ahead and give those a whirl, and then whenever you're ready to be checked, unpause the video and see if you got it right. All right, so on the first one, again, I picked the same points, -1, 0, 1, and 2. When we get into more graphing, we're not always going to pick these points, but for the sake of this lesson, that's what we're going to pick, okay? When we plug those in, we should get -4, -5, -6, and -7. So your solution point should have been right down here below the x-axis, okay? All right, looking at the second one, same idea. Still plugging in -1, 0, 1, and 2. When you plug those into this equation, you should have gotten 5, 2, -1, and -4. And when you graph those solution points, you should have gotten something that looks like this. Okay? All right, so that is the end of the Cartesian coordinate system and graphs. So this assignment is now due in your Knewton homework. So go ahead and get that assignment completed. If you have any questions, just let me know, okay?